to give you what the event's going to be like, what the evening's going to look like. As soon as everybody's settled with their coffee break, a session with Jam. He'll be talking about the current state of conversational AI and its future. For those of you who don't know Vishnath Jha, he's the founder and CEO of Sarthi.ai. Sarthi.ai. Sorry. Don't know what happened. Check, 1, 2. Sarthi.ai, multilingual conversational AI. His primary research involves NLP, speech technology in low resource language. He's also part of the government. He's working with a lot of cool projects. Responsible for designing policies and frameworks to spur up research ecosystem in the Indian languages. Following this session, we'll have another small coffee break, after which we'll have a session by Saurav Mazumdar. He'll be talking about the AI landscape and the Industry 4.0. For those of you who don't know, Saurav at a fine. They're actually working on a lot of cool projects. After this meet and greet session, so you'll get to meet both the speakers, and you'll get to have a small networking as well. We also have a small feedback form. You'll notice they're placed on your chairs. I would request you guys to kindly fill this out. We want to know what your thoughts are. I want to see how we can do it better. Is there a coming up? Give it happen for you. Yeah. Talk about dialogue. An open platform where everybody gets to talk about the relevant issues, and really just get all practitioners together about all the stuff that's not being discussed. The best thing about this is that's great. And without further, can I have one? Thank you, guys. Hello, everyone.
Okay, so I know you guys are back from lunch, so a little drowsy, or maybe I'll try to keep it engaging. I'll speak for, say, cover, and then I'll like to keep it interactive. If you have any questions, feel free. I would like to answer all of them. And if we are, if you run out of time, we have networking sessions where you can connect. All right? All right? Yeah, that sounds like an audience. Okay. All right. So let me see what I have got for you. So, okay, so how many of you know or heard of conversational AI before, or you have some sense of idea what exactly it does and where it can be used and all that? Some who has the idea about that? All right. Okay, so audience is mixed. Okay, I'm like 3, 4. All right. How many of you have used Google Assistant, Siri, Alexa? Yeah, there you go. So these agents are actually conversational AI assistants, basically. I'll talk about that as long as, if we move ahead. Some glitches. No worries. Move it, yeah. So, it's not coming up? Some issues, yeah. So, okay. So in the meantime, now that I have an audience and I know that most of you have heard about or know some sort of conversational AI assistants. So, what are the basic problems that you faced while using them? If anyone, volunteer. What are the basic problems that you face when you talk to a bot or a human? No, like there are two different things, right? When you talk to a human, they respond back very sensibly, very, like accurate, precisely. It is, like we are supposed to do that, right? But bots often don't do that. So what are the problems generally you face with them?
Accent.
Sorry?
Accent.
Accent, yes, accent is one of them. Yes, absolutely, yes.
Sometimes Siri says that sorry, it is beyond my capacity.
Yeah, because they can't, okay, I'll talk about that as well, yeah. Okay, so we have certain senses, flat responses, accents, not able to understand, right? Three problems that we just figured out. So if you can move the slide, then I'll just do that, yeah. So what do I have for you today? So I'm going to talk about what is conversational AI. A brief overview of how it evolved. So it's not very new. It started way back in 1966. Even before that, 19. So he had some concept around it. So first bot was Eliza, and we'll talk about that. Then I'll talk about a couple of things like what are the two different types of conversational AI assistants, like the goal-oriented dialogue systems and open domain question answering systems, basically. So this is like English. In the first introduction, I'll talk about, this will be limited to English as a language. Now coming to the problem when it comes to the Indian languages or any non-English languages, which are often referred as language. Largely the data sets, the internet around us is limited to English. The primary research areas are always in English. Corpuses, like Indian languages have been, so I'll talk about how things are done today in industry. If somebody wants to make a conversational AI assistant in Hindi, let's say, or Tamil or Telugu, or maybe like Afrikaans or Malay, any languages. So how does it happen today? How do we do? I mean, like how we did it in 2019, and like state of the art. So industry and state of the art are two different things. What is practiced in industry is different, and so I'll differentiate two of them. Then I'll talk about what's in store in 2020. What are we going to get in 2020? So largely these are the anchors. Also I'll talk about market adoption and potential. Probably it's a error. Probably I forgot to remove. But anyways, next. So what is conversational AI assistant? We all know it is like some software program. If you say something, it gives you a response back. Right? Chatbots, you see, it's a very common term. In common parlance, we say chatbots. But chatbots and conversational AI assistants are two different things. Chats are like a high-end version of RPA. Like, it doesn't allow you to navigate the direction of the conversation as per the user's will or your will. If it is a chatbot, it is a fixed response. They give you 3 responses. You have to choose one of them to move ahead in the conversation. That is chatbot. Okay? Conversational AI assistant is an AI assistant which basically understands your natural language. Like we talk, that way the bot talks, right? They understand free-flowing natural language conversation. They understand on the fly. You engage. It is a multi-turn dialogue. It's not like command-based. You say something, some action is taken. It's a multi-turn dialogue. You say something, then you say something. The bot something, right? That's how it works. So I think, and this could the medium of information, the medium of input can be anything. It can be a touch, it can be a text, it can be a voice, audio, right? Voice UI have been very, it has been on the rise. I mean, although it started in 2000, early 2000 or mid 2000 basically, but of lately after Siri came in, everything flown in. Like Microsoft Cortana came, Google Assistant came, Alexa was acquired by Amazon. Alexa started coming. So it was like whole new breed of conversational AI assistants started to. What next for us? Is out of these assistants, these were always like B2C game. There's end user consumer who's talking to the bots, right? And the scope is just unlimited. So you can ask about when did India get independence, and also you can ask how to boil water, right? All sort of questions. So the scope is very, very difficult. So that's where the next slides comes into picture. So this is the evolution part. Yeah. Talking about Eliza started in 1966, Alice, and 2013 you would have seen a movie called Her, where a man falls in love with a bot, right? So that movie was based on Alice. Okay. So then Smarter Child came, IBM Watson 2006 it started, Siri 2010, and 2016 came Facebook Messenger. Messenger just blew us apart because from 2016 to 2019, now we have 300,000 on Facebook Messenger's platform. So the rise, whatever we had till 2016, that just got flipped on the other side. Good. So, and that's when the innovation started flowing in, because businesses became aware that this is the actual problem. Whenever there is a business talking and there is a consumer wants to talk to a business, so there is some conversation, and that conversation mostly it is about some particular things. There is a different scope around it, and there are different type of questions around that scope, right? So that started giving enterprises some sort of idea that if I put some assistant around it and my customer touch points or in my internal touch points, wherever there is conversation, I can automate that. And that will basically free up the human time to be more productive and be more creative and be more relationship oriented. Exactly. Right? So the two parts I was talking about, open domain question answering, the goal-oriented dialogue system. So these are the two ones. Open domain, you just ask anything. It's a sequence to sequence architecture. You train on a large corpus, and based on that, you ask random questions. Like as I said, if you have trained that open domain QA system on Wikipedia, you can ask, okay, when did India get independence? And this will be a factoid answer, right? A sentence, a query, but the answer is a fact, like small. So what will be the span of words in Wikipedia article? That will be the answer. So mapping the query to that answer was, that's how we developed our first open domain QA systems, basically. Okay. So why we are doing it? Because it is needed. It is needed. Why? Because in an enterprise setup, it is different, because you have some goal that you need to fulfill. Nobody calls customer support to have a fun, right? Okay, nobody calls customer support and says, "Tumhare ghar mein pani aaya kya?" Nahi bolta koi, right? They have to get their job done and they have to get away, leave it, right? So enterprise was a very, very good area for conversational AI to get in and make its, little move ahead. But open domain is largely a research problem, because no matter if it is a business setup or it is a non-business setup, people, and it is the dialogue itself, it's so innate to human psychology that whenever we talk around something, we never say everything in one go. Whenever there is a dialogue, there is an exchange of information at every turn, right? You say something, let's say if I say, okay, what's your favorite movie? So somebody will say XYZ. I say why? So I like the actor. So what is special about the actor? So this is a conversation. The topic still remains movie. The context still remains movie, but there are a lot of questions around it. So, and in can be just anything. So it's not particularly for use cases where enterprises can be helpful, but when we even in customer support, when you talk, many waiver. You're talking about something, then switch your context, move to something else. You are booking a hotel, suddenly you will say, okay, what is the temperature there? Hotel assistant should not know what is exactly, the weather temperature, right? But still, it has the user, the consumer will ask, because it is consumer, right? So it can ask anything. So to get the flavor of open domain QA system into the goal-oriented dialogue system, that's where the actual conversational agents will happen. And we are far from that, actually. We are far from that. So where the innovation is heading? Innovation is largely heading towards the goal-oriented dialogue systems, because in itself there are a lot of research problems that still need to be solved. Okay. So how generally, so multiple conversational AI systems, how actually they are today. So terms of text. Right? That's step number one. One text. Now that text is an unstructured text, right? Unstructured data. You have structure. You have to find the intent out of it. You have to find the relevant semantic constraint around it. You have to find it. There are entities, sequence labeling tasks, semantic role labeling, multiple. And then the third, once the unstructured to structured part is done, then the bot needs to generate a response. And like what needs to be done. Sometimes you might need to make an API call. Give a plain text response. So how to decide? So that task is the dialog manager. And once the response is generated, that text response has to be synthesized in terms of speech. So that is text to speech. So that is how a conversational AI system in English works today. However, when it comes to the low resource languages or non-English languages, it becomes difficult. Why? Because we don't have much data. The content that we have, and like internet also. I mean, like how many of you know that there is a language called Marathi also, and they have like around 30 million people who speak that language. There is a Kanaujiya, which is a dialect of Hindi, and that dialect itself is considered as a language because the dialect has another dialect called Kanaujiya. The accent you are right now. So the dialect which was spoken in the southwestern Uttar Pradesh, eastern Haryana, and southeastern Rajasthan, in that pocket, below Delhi, that is where it was spoken. Until 19th century, there was no such thing called Hindi. Hindi was a school of languages. So there were like many dialects. If you go before 18th century, I mean Hanuman Chalisa, if you see, it's written, it's in Avdhi, or Braj Bhasha. Like the different thing. There was no literature behind it. So this became mainstream in 19th century when, people like Munshi Premchand, they started writing and formalizing Hindi as a language, and we started post-independence. So that's how it happened. So if somebody says that, so multilingual, I was trying to explain, what is the scope of the problem? Right. In India itself, we have around at least 18 major dialects. 18 major dialects. So it takes long time to solve that problem. So how we do it, because since English was solved, so the natural way was to solve a problem for multilingual conversational AI was to translate the user input to English, right? But for that, machine translation systems has to be very accurate, right? Which they are not, right? If you say कि हिंदी से एक इंग्लिश सेंटेंस में ट्रांसलेट करना, I'll give like पीयूष को 500 रुपए ट्रांसफर कर दो, so that दो will be TWO in English. So, and whenever it is since conversational AI largely where I work is in customer support, pre-sales, post-sales, it's okay, but it has to be customer support. So that time it becomes difficult because when the product is in hand of a user, you can't afford to make mistakes. One bad experience and you're out of the game. So when you are working in a consumer setup where the product has to be very robust, and if you rely on translation, no, that's not going to work. That is step number one. Step number two is, which we ignored, and I mentioned speech to text. So speech to text is good. I mean, if you have 10,000 hours of annotated data, probably you will get a good ASR in English or Hindi or any other languages. But I mean, we all know how it works, right? Kannada ka agar if I have to do a speech to text, I know how it works, right? So before the input, I said something in Kannada, that needs to be first transcribed. After transcription, that needs to be translated. So there are two steps where error can be propagated and magnified because of each other. So by the time the user input reaches the language understanding engine, it's already corrupt. All right? So you can't blame, and or SLU, basically systems, basically that these are not performing well. They have low confidence. You can't say that because the input that you are giving is itself is very. So how to solve that problem? So that's what I was working on. So how it works basically? I mean, like if you see the slide, it basically says you said something, speech to text, then translate with Google, Bing, IBM Watson, and all that. You put that. Then there is a semantic frame which basically understands input hai, so it has to have like a some intent. Whenever user says something, there is an intent, right? Even if you say okay and something, you want to ignore sentence that whatever other person has said and move ahead in the conversation, right? The next difficult part comes in. How many of you are from northern part of the country? Okay, cool. आप लोगों ने कभी किसी जब नए लोग से मिलते हैं तो do you say Ram Ram? And when you leave the country also you say Ram Ram, right? Same conversation, same audio, same text in same conversation, but at two different position means two different thing. At one state, it says Ram Ram when you are meeting first time. You are expecting a like greeting and you are starting a conversation. But at the end, when somebody is saying Ram Ram, then it means conversation has to stop. But how will a machine understand that? Right? When there is no differentiation except the position, the state. So that's why dialogue state tracking becomes very important. If just somebody has some language understanding engine, which largely people have, because it's somewhat simpler. But yeah, some people who have been working in that space can actually solve that problem for a while. So that becomes important. Then comes the third part, the policy part. So now that you have understood that, okay, this is the state, this is what user has said, now what I should do, what is the action that I need to take? That is done by the dialogue policy. It decides. Okay, now I have to give plain response, or I have to give like a, make some API call and get some features and render in front of the user on the front end, right? You do that. So, and once that happens, you generate the response, then that response is again translated in English, and then speech has to be synthesized. I mean, the Hindi, you generate the English response, then that is translated to Hindi, and then the speech for that Hindi output that the translation engine gave has to be synthesized. So that's how the circle moves. However, this is not the most appropriate way of doing it. We established that there are two major loopholes, translation and transcription. Okay, so what happened in 2019? So we removed translation. First step was, the easiest thing for us was to remove the translation part. Why? Because we saw that is where like we face the majority of our problems. Like if I have to build a bot in Haryanvi, it's difficult. I mean, I don't have content. I don't have large text corpus on which I can build my language models. So how do I work on it? So, and if I am trying to translate using Google Translate or Bing, it's not working. I have established that. So what is native? That for each of the languages, you generate content, no matter where it comes from, do scraping, do mining, web mining, anything, content, and then with a large corpus, you build language model for each of the languages, right? So in that manner, we succeeded a lot, and this area, early 2019, especially after Elmo came in. How many of you know about Elmo? Okay, so how many of you have an NLP background, by the way, just to cool, so I have to dumb down a little bit. Okay, so yeah, so all right, no worries. So what happens is, so when you are trying to so you must not be aware of what is language model, right? Okay, cool. So what is a language model? So language model is the ability to predict next word. आप WhatsApp में कुछ type करते हो ना? So you get suggestions, like 3 options, what are the words, where does it come from? Language models. T is equal to 0 पे आपने एक word बोला, तो T is equal to T plus 1 पे क्या word will be the most appropriate? Based on a large corpus of text which you have given the machine to learn. The relation between the words. Co-reference क्या है, syntax क्या है, sentence कैसे form करते हैं, all that stuff. So that is what we learn in language model. And once, so basically, if I have to give an analogy, so it is like language model is teaching machine to form sentences, word sentences. It is not able to understand it, but it can form sentences. Okay? Because it has seen so many sentences, large corpus of text, that is knows अगर यहाँ पे न्यू बोला है तो न्यू दिल्ली हो सकता है, न्यूयॉर्क हो सकता है, but अगर आगे किसी ने अमेरिका बोल रखा है तो it will generally be referred to न्यूयॉर्क. So that semantic relationship between the words, that they understand. So that is like the language model's task. So अब नई चीज है, उसके बाद next what happens? You have formed the sentences. So next task comes intent identification or entity extraction, which are the two major tasks globally. Whoever works in NLU, they are generally aware of that. So intent is कि I want to book a movie, right? Movie ticket. So movie ticket के लिए क्या हुआ कि book movie or book tickets for movie will be an intent, right? Okay, movie is a variable. The value of movie can be changed, and the user hasn't given movie name. Which movie? Right? So they are correlated. Intents and entities are correlated. So first thing begins with intent. How do you how do you figure out the intent out of a user query? That happens, simple classification task, right? Classification. When user said something, that query has to be classified. Out of 10 intents, what that intent labeled against this query, right? Second part comes that I have talked about movie, but I haven't given the movie name. So I haven't given the theater, I haven't given the number of tickets, I haven't given the time. So all these questions are slots. These are called slots, and slots are filled with entities. Entities are what? Information. मुझे दिल्ली की ट्रेन बुक करनी है, तो दिल्ली is destination, right? This information, this clue, this is called entity. And with this entity, I fill my slot. अच्छा, destination मेरा क्या है? Okay, so intent and entities and slot, we are okay. We got that, right? So that's how the language understanding component works generally across. कि इसका user ने query दिया, उसका intent क्या है, entity क्या है. Once you have got it, and take some action around it. But when it came to Indian languages, as I said, we didn't do translation, we built language models, and okay, cool. So, okay. So once we have built that language model, that sentence formation thing, once machine knows how to make sentences, what is the next task? I said classification, right? That means you have to teach the machine to say that, okay, this sentence means this thing. Machine already knows how to form sentences, that it is a sentence or not, right? Now it needs to know which label to associate with this query, right? Simple classification task, text classification task, right? How do you extract entity from the user query? That is called, standard name for that is called named entity recognition, NER, and it is one of the sequence labeling tasks. Named entity, as I said, it can be name, person, organization, location. These are the entities, and then there can be multiple custom entities that you build based on the business requirement, and they have a particular format generally which we follow. It's called BIO, begin, inside, out. So so the data has to be annotated. So how will you teach machine that this sentence means this thing? You'll have to give some data, right? Supervised learning. Supervised learning, how many of you are aware of? Cool. So that means supervised learning is you tell machine, this is the image of apple and this is the text. That means whenever you see something like this, you mean this, text, apple, right? So similarly, that this is the query, this is a sentence. Whenever this sentence comes, this means this particular intent and this particular entity. Once you have annotated this data in a particular format, now you do the training part. And your model is ready. It might take maybe like 3 days, 4 days, or maybe like 20 minutes or half an hour, depending upon which configuration of GPUs and how much amount of data that you have. Okay. Now comes the second part, the episodes and plots. Okay, if I were to ask you, how many runs will Rohit Sharma make in next match? Or maybe Virat Kohli, or maybe like AB de Villiers or anybody. Or maybe like Ronaldo, how many goals he will score in next match? You will have some random answer. I mean, random. You are not sure of that answer, but you will have some random. You can give that number. You can split that number, right? How? How does it work? Exactly. Based on past history, recent history, and there are multiple parameters around it, which helps you take decision in like what to split, what to give answer. So that's what happens in this here also. Bots basically, they are nothing, right? They are software programs. They don't know anything. So what they are trying to do is they are trying to imitate the conversation making capability of humans, right? So first part you are done, that you have got the unstructured part, you got it structured. Now it comes to what response do you need to generate? The state tracking part. Which state in the conversation you are in? If you are authenticated, do I need to authenticate again? No. So during the call, if you do it once, it is done. So this kind of the finite automaton normal languages you would have read in college, computer science backgrounds people, IT people, right? So that comes into picture. So how to design the states? There is a final state, there are intermittent states, and how do you navigate those states in a best possible manner, right? So, and for that, how will it happen? You can't, there are one way, there is another way to do it, write rules. Acha, ye if aaya to ye else. If this if, then else, then that, like nested ifs basically. But that is not scalable. Ab aisa to nahi, I mean like a movie ticket if I have to book, but the conversation that I will have with the agent or the bot will be very different from what Saurabh does, or maybe what you do, right? But the context and the intent will be same. But the order of queries will be different. So rule-based system won't work, right? It has to be a scalable system which is able to make sense. इसके बाद मुझे ये पूछना है, right? So how will that happen? That will happen when you give some experience. You have to seed the agent. You have to put some seed in the agent's brain. Now I know if something like this, if this state is fulfilled, and user had said this intent, I have to ask this question. You give some samples to learn, right? Once it has the seed of information, it grows with time. The more you talk, better it gets. More plots, right? That is what. So that is how the second part comes, the response generation part. On this. And then, yeah, the policy things, like which policies are, there are multiple policies around it, so which policy to do, there's memorization, because already if the user is following a particular journey, which is already in the seed, so there is no need to do anything else, just follow that whatever seed is there in your, I mean, to simplify it further, so memorization is one. I'll give you one example. What is the one of the policies is memorization. So I was talking about seeds, multiple stories, multiple like plots, multiple episodes of the same plots, right? So based on that, if a user is somewhat following a similar episode of a particular plot, then bot doesn't want to do anything else, because you just have to follow and it will get to a final state, right? So that's how basically it works. The dialogue policy thing. And then again, once the response is generated, you can ask me now also, it's fine, yeah. Which could be?
When there is a response, the dialogue, right? It's in that holistic handwork, which next step should what, right? How does it be?
Yeah. Yes. So there are a lot of things, and there are as I said, memorization is just one of the policies. So there are multiple Keras policies, there are multiple other policies, the proprietary things that we have done. So basically, okay, so let's say, forget what algorithm it is, understand the problem. So you are saying that there is some algorithm based on which the response is generated. But forget algorithm and see the variables. the response will depend on what? Last input, or maybe last 5 inputs, or maybe what's the top context, what is the domain, what is the intent, what is the entity, right? And maybe like last policy, when the user said something last, what was the policy that was taken last time? There are multiple variables on which you can do something, and there are reinforcement learning algorithms. Yeah. So that is how it works basically. So basically, so it works and didn't work. Okay, so there are 2 things. If I understood you correctly, you said that, okay, there's a bot, it talks to an agent, sometimes the bot gives correct answer, sometimes it doesn't give the correct answer. You have to come little further.
Like, being correct is also very relative, right?
Yeah, but in what context? Unless you tell me the context, I can't say.
I'm saying, let's say, I'm talking about the reinforcement learning, right? How do you know, how does a bot know that whatever I discussed was the right way to propagate, and given the next iteration?
So as I said, so we use the plots and the episodes. Okay. Let me explain what are plots and what are episodes. Let's say movie booking, or hotel booking, or let's say customer support में some particular issue, one particular order delivery, मेरा order कहाँ है, right? Order related context. So if you build it around that bot, so there will be multiple questions, and I'll have certain information, certain prior history of the conversation, similar conversation, and I have given that to the bot. So now what happens is, if according to the memorization policy that we use, what happens if user said something and we are like, let's say 3-4 turns into the conversation, if there is something exactly similar to the story that I have already put in, the plots that I have already put in, it will follow the same story. Whatever is happening in that story, it will do. Next thing is, if the user is not following, and the bot is not following the memorization policy, because that is also a choice, when to follow memorization policy, when to follow the Keras policy, and like other different policies basically, right? So that decision also is on the dialogue state, the dialogue policy learning basically. So that conversation decides. You said that how does the bot decide basically which conversation is wrong, which conversation is right? I mean, like sensible or which is not, as per the response. Is that what you said?
Yeah, so my main thing was, the second question was, when you do a conversation, does it learn on the fly that did make sense?
It will never learn on the fly.
That's what I'm saying, like it's all contextual to the previous knowledge set or whatever it's maneuvering,
that
right?
is there, that is one part.
But let's say we are talking, right? You're learning on the fly, is it making sense or not?
Yes.
So is there a way to do that today? No.
Not yet. So what needs to be done is, so basically what happens when you say something and bot is not able to answer, or you get some irrelevant response, you have to figure out. So there's a paper probably I would like to recommend, you can read that. That is the research of direction of research in which it is going. So what happens is when you try to, you have to flag basically. You have to flag that this is an irrelevant response, and all those stories which are flagged are not used before processing in retraining the model. So once those conversations which has to be taken, it has to be it has to be trained. Okay, यहाँ response क्या गलत था? Why? Maybe like confidence is low. Maybe like the state is not fulfilled. There are n number of reasons around it. So unless you get that data, it is not possible. Not yet.
And how do we flag? I mean, is there a way?
Yeah. So there are tools basically. So what happens is generally how we work is like it's always a hybrid approach. You're talking to a human, I mean like bot, and bot is programmed to answer questions which is in its universe, right? You have programmed the bot to answer 20 different questions. It will answer anything around those 20 questions. But if you ask anything else, so basically the bot will break when? There are 3 cases when the bot will break. 1, bot is not programmed to answer that question. Second, bot is programmed to answer the question, but bot faltered, low confidence score. The query it was not able to understand, right? And third, the bot said something, but the user couldn't understand. So these are the only 3 cases where bot breaks, psychologically. Okay? So you have to flag, based on that. Whenever we have to preemptively, and how do you identify that bot has broken, right? So, generally, whenever the bot gives you irrelevant response, what do you say? क्या बोल रहा है? What are you saying? Are you dumb? So you have to get those signals out from the conversation. Okay, now bot has said something wrong. So the control of the conversation goes to the human agent. And human agent has a console around it. And now human does the conversation part. And wherever there is wrong, it tags. Okay, this is wrong. This has to be this intent. And that is taken as a static number, absolute number. So that's how it works. So conversational AI is not in a state where it can be independently matured. That's why, as I said, open domain QA is completely different ball game. When you come to the goal-oriented analysis, different. It's an enterprise setup. All right? Cool. So we can actually move it. Yeah.
One more question.
Yeah, sure.
So like in WhatsApp when we are typing, so earlier WhatsApp did not support the Hindi words.
Yeah.
But now over time, and it's different from person to person, as soon as I can say, ho will automatically
Yes,
come in, right?
yes.
Or if I write kiss, time pe aana hai, to wo time will automatically come in because in my history, I have always used ho after kaise.
Yes.
So, but then is the model retraining and how frequently is it getting retrained?
So every day you will see, probably in my phone, in my WhatsApp, what happens every day 2 a.m. my data is backed up. Okay, and based on and then whenever there is, and it could be based on time, it can be based on volume. कि इतने टाइम का डेटा हो गया वापस रिटेन करेंगे या इतने वॉल्यूम का डेटा हो गया फिर हम रिटेन करेंगे. Okay, that's how it works. So that's why, and what you mentioned कि वो कैसे के साथ हो कैसे आता है या किस के साथ टाइम कैसे आता है, is it like you write in alphabets, English alphabets?
English alphabets,
Exactly.
yes.
So that is called Romanized Hindi part. So your representation is of that language is English alphabets. So I'll talk about that. That is another emerging trend that is coming up. Not emerging, but emerging in terms of like to near some sort of substantial improvements. Okay. So there is something called Facebook XLM, probably if you want a Crosslingual XNLI. There is a data set on that XNLI, which is X stands for cross. So you can build your systems, you can test your system on that basically data sets. All right. So that happens basically. That has to be backed up. And the best part is you just don't say same thing with you. There is somebody else also who is the same part. कैसे के साथ हो दूसरा बंदा भी use करता है. Somebody else also use kiss ke sath time. So whatever is frequent, it gets up there. So it's like a filtering and getting the information distilled.
Question.
Yeah.
Most of the conversation.
One sec.
Most of the conversation that actually happens in India is.
So most of the conversation that happens in India is English. Around 80% of the people talk in English. So then, how do you then, ensure that what is coming in Hindi and what is coming in English, because as you say, Romanized Hindi is mostly used there. Okay, so because building and say annotating so much amount of data is also not possible because you never get to know what the finite boundary of the data will be.
So that's why it's actually a separate area of research around it. So there are couple of ways to solve it. One of them is like again cross-lingual NLP. Again, what you do is you have to train models in such a way that both the data sets, whatever data set that you have in English or in Hindi or in Tamil or in Telugu, you train this data set together and make one single model, just like multilingual bird, right? That is one way of where the embedding space is shared between different languages. You getting? So I work on that. That's why I can tell you that a little bit. Yeah. So, as I said, this is one area you have to find. There are a lot of areas which we are exposed to. That's why we know. Otherwise, we don't know. Just like bots. Okay. Zero sort learning. Yes, it is. It is actually zero sort will be like few short learning is what people generally use it. But still, that is long way to go. Long way to go. Yeah, that works in the speech side. When you do speaker identification, from your audio you want to identify who's speaking, there you can try many a time.
In reference to what she said, she just mentioned it for WhatsApp, that like in conversations that happen. Mm-hmm. But I think whenever I use my browser or in any messaging app, it happens for notes also. So basically everyone in the Android domain, like the Google is the main data keeper. So does it retrain model every now and then? And like it is not possible. So how does it?
I can't tell you about it because I have zero information about how Google does that. Okay, I can only anticipate. Because as a technical thought process, technical approach, how they would do. Because they are taking my data set at 2 a.m. in the morning. So if there is some new word, some new, vocabulary that has, irrespective of the language, if it is there, they'll pick. How they'll pick, God knows. It is with them. So I generally don't have any idea around it, why they do it this way or what is the way exactly. Because a lot of things they don't disclose.
Yes, we don't see Google backing up every now and then, just like WhatsApp every day.
Google doesn't need to back up. You have already backed up a lot of information already, so you don't.
You don't even have a gist of how does that happen, like a basic gist, because starting learning with deep learning, we ourselves thought the same thing, the same question, like how does that happen?
What precisely formulate your question?
Like how does like kaise ho in like every other thing in the keypad we type that happens.
Yeah, so it depends ना. Whenever you are typing with keyboard, right?
Yes.
So Google कीबोर्ड Gboard यूज करते हैं, Google कीबोर्ड यूज करते हैं. आपको क्या लग रहा है कि आपका डेटा वो आप टाइप करोगे उसको फ्री में यूज करने दे रहा है, कुछ भी नहीं लेगा आपसे. How will they make money?
You cannot train a separate model for every human.
Yes.
It has to be a repetitive.
It will consolidate. I was talking to her, right? I was saying that it is not just that it's a language construct. And there are some popular language constructs. Some अभी कुछ लोग क्या करते हैं कि KESE भी लिखते हैं कैसे. कुछ लोग हैं जो KAISE भी लिखते हैं. But again साथ में हो लिखते हैं. So semantic reference जो हो के साथ कैसे और कैसे दोनों आता है. So it knows कि कैसे और कैसे similar है. दोनों same context में use होते हैं. So they are, this is how they understand. How do they get the data? It's very simple basically. We have given them access. Okay, so yeah, so now we talk about few key emerging trends in 2020. What we are working, what we are expecting, what is happening in interspeech. One suggestion, one recommendation for all of you, if you want to pursue anything related to NLP, deep learning, or computer science. Not computer vision basically. Speech. Follow the A++ conferences basically. Something like interspeech for speech-related research, ACL, ICML. There you will find actually what's happening. So I generally get my information from there. Okay, I read papers. I know this is working, this is not working, why this is not working, this is working. Based on that, I formulate what needs to be done. Okay, cool. So now one of the very in my area, in my domain, conversational AI, one important breakthrough probably, or the seed of breakthrough came last year at Interspeech 2019 when somebody tried to cut down the transcription part also. So as I said, there were two parts, right? Translation and transcription. Translation we already removed, translation, but we are still heavily reliant on speech to text for low resource Indian languages, which are not up to the mark. Okay? My NLU is good, but since I'm not giving it accurate input, it's not performing well. So what should I do? I have to cut down the transcription part also, or we have to normalize. Whenever you try to normalize the user query, there will be some changes, and there is more chance of getting wrong results. So what to do? Remove the transcription audio, label that. And how are we going to do that? Same approach. Just like NLP has its ImageNet moment, speech will also have, and which actually did something like BERT they did for phonemes. So just like we have word-based language models, they have phoneme-based language models. So one language model which you fine-tune for different tasks. Right? So that is one area that we will do, because in our earlier approaches, wherever it was spoken language understanding, people were like, that is the only way we can do. But it is not the accurate way of doing it, so there is no point doing it. So you do a thing which is difficult, but it is the right You don't want corruption in your input before it goes to NLU, right? So that will only happen if you give directly speech to intent. If you, whatever the speech audio file is, the WAV file that you generate, what is the intent of it? And once you have got the intent, you will find the slots and everything around follow-up thing. So that is one area that we see that is gonna, like rise further in next maybe like couple of years, 1 year, 2 years. We have already got couple of data sets. Google released some data sets that was command based. That means it was just single turn. Like Amazon का review, product का review लिखना है, तो product के बारे में कुछ बोला, एक review लिख दिया, एक बार क्वेश्चन पूछा, एक बार जवाब दिया, खत्म, conversation खत्म. But normal life में ऐसे conversation नहीं होते हैं, right? It is more of like you say something and multi-turn dialogues basically. तो एक तो ये problem थी. दूसरी you mentioned flat responses. कि मतलब like you say something and the response is not there. हमेशा गुस्सा के बोलो तो भी same response, हंस के बोलो तो भी same response, right? So generally ऐसा होता नहीं है. So in order to pass Turing test, you need to take control of that also. So just like how we talk about it, but yeah. So speech to intent is one part there which will solve our problems, where the translation part will also go on, transcription part will also go on, and we are like right in the game. So then we further build on top of it कि उसको और अच्छे से कैसे कर सकते हैं. If I have to cancel noise cancellation audio में कैसे कर सकते हैं, so that it is pre-processing the audio files before it is given to the NLU, spoken language understanding engine, right? So that is one emerging trend. Next will be the cross-lingual SLU again. So you see, like this is from this guy from he works with senior research scientist Dr. Manaf Faruqi from IIT Kharagpur. He is there, and he along with Mr. Dr. Sam Upadhyay, they wrote a paper last year, and very fantastic paper, and they worked on it. So what they did was they tried Hindi and Turkish, 2 languages along with English. They try to test कि अगर हिंदी में डेटा सेट नहीं है मेरे पास तो I have to bootstrap, because like finding a conversational data in itself is difficult, and if I add one more difficulty layer कि अच्छा हिंदी का चाहिए, टर्किश का चाहिए, very difficult. You won't get it. You have to either synthesize it. Synthesize करने के लिए you will need a lot of money, you will need a lot of manpower, you will need a lot of time. ठीक है? So that's an established fact that this is a difficult problem to solve. Now, so but क्या है problem? What is advantage that we have? We have a lot of English data set. We have lot of English data sets. At least language model के लिए web crawl corpus हमारे पास बहुत सारा है. Conversational data के लिए we have ATIS, Snapes data set, RL data set. There are multiple data sets on which you can test your English conversational AI assistant. Because English में translation की जरूरत नहीं है, और transcription more or less it is workable. And wherever there is something wrong, you can fix some, you can do some error analysis कि कहाँ पे कौन सा word गलत हो रहा है, and based on that you can write some rules to support it and get it going, right? But अब यही चीज हिंदी में करना है तो दिक्कत हो जाएगा. तो कैसे करें? So how do we do it? So what we do is we take English data sets and like whatever we have learned in English, the intents, while training we give smaller amount of जो humanly possible है, which is not heavy on your pockets, not heavy on your time. So a small amount of Hindi data along with large amount of English data. So what happens? And you tell that okay, ये word से related ये है. Due to larger vocabulary, you are able to capture the relationship between the large number of English words with smaller number of Hindi words, vocabulary. So you are sharing that embedding space. No? Okay. Cool. So basically that's how it works. So you are bootstrapping. So जहाँ पे हिंदी में data set आपके पास नहीं था, you didn't have lot many data sets. What you do, you use English as for bootstrapping, and then fine tuning on the whatever Hindi data set that you created on your own, a small amount. Per intent, 100 sentences if you have, you will get good results. And that's what they did in paper. So while training, एक बार हिंदी के साथ English train किया, एक बार Turkish के साथ English train किया, and they have raised the F1 score very very high related to any जो state of the art results थे, they improved it a lot. Which one? No, so basically this was domain. So basically ATIS is always for travel. ATIS is always for travel. So ATIS dataset is actually from Microsoft CNTK. So they released that. So, and again they have multi-turn dialogues. They have cleaner version also, noisy version also. Depends how you want to use it. Like that. Next. Now, this is one very specific area I'm very excited about, and I've been working. My team have been working around it. So, NLP में अभी if you are, I'm sure if you are working in NLP in 2019, you must have heard of word called BERT. B-E-R-T, BERT. You must have heard of. Why? Because it changed the game forever. Right? Why? Because the accuracy and like the traditional method approach of solving a problem, deep, you used to hear, right? Deep learning, बहुत data लगता है. You need a lot of data sets, right? Action करने का, transfer learning, right? So, but problem क्या था कि BERT ने तो किया सब कुछ. I mean, they used transfer learning. They used like 334 million parameters, and it started performing results. जितने भी जो SOTA benchmark हैं, state of the art benchmarks, out of 2017 में it just crossed everyone. One single model. How? It did something well. But what is the downside? अब accurate तो कर रहा है, but what is the problem is that the model size is too heavy. That means inference time is very large. अगर एक क्वेरी दिया तो उसको अंडरस्टैंड करने में उसको 4 सेकंड लगेंगे, बट कन्वर्सेशनल एआई सेटअप में दैट वोंट वर्क, राइट?
इसीलिए तो हम ट्रांसफर लर्निंग करते हैं ना, कि खाली जो ऑलरेडी पैरामीटर्स उसे याद रहेगा और एक ही
जब आप अनपैक करते हैं मॉडल को तो मॉडल साइज इंक्रीज होता है ना. अब जैसे मान लीजिए आपको एक बर्ड बेस्ड ट्रांसफॉर्मर बेस्ड मॉडल अगर कोई भी आप यूज़ करना चाहते हैं प्रेडिक्शन के लिए, तो आपका इन्फ्रेंस टाइम जो होगा उसको कम करने के लिए आपको जीपीयू यूज़ करना पड़ेगा. जीपीयू कम्स कॉस्टली, कस्टमर तैयार नहीं है आपको पैसे, क्या करोगे आप? यू हैव टू फाइंड लोअर मॉडल साइज, हैव टू लोअर. दूसरी बात है ये तो हाउ दिस विल वर्क व्हेन वी वर्क एज अ एपीआई सर्विस, कि भाई एक लैंग्वेज मॉडल बना दिया, यहाँ से यूजर क्वेरी लिया, एपीआई हिट किया उसको, उसने जेसॉन में मुझे फॉर्मेट करके दे दिया. इट वर्क्स देयर. बट अगर आप मोबाइल में बात करना चाहो, हाउ इट वर्क? मोबाइल का रैम तो बहुत छोटा है, मेमोरी बहुत छोटी है. हाउ विल इट वर्क? सो इट हैज टू बी कंडेंस्ड. सो दैट पार्ट इज कॉल्ड नॉलेज डिस्टिलेशन और मॉडल डिस्टिलेशन. And that has, there are a lot of very exciting papers, very exciting results around it. जैसे to name a few, जैसे आपका QBERT हो गया, DistilBERT हो गया. So they are all BERTs. They are all transformer based, but they have reduced. जैसे कि मैं एग्जांपल देता हूँ, गूगल का जो BERT जो उन्होंने रिलीज किया था 334 मिलियन पैरामीटर्स के साथ, सेम डेटा सेट पे उन्होंने एल्बर्ट उन्होंने रिलीज किया जो सिर्फ 18 मिलियन पैरामीटर था. तो यू इमेजिन 334 से 18 मिलियन पैरामीटर्स, परफॉर्मेंस में कितना गैप? 0.4%, 95.6% से लेकर 95.2%. सो यू वुड वांट दैट, राइट? बिकॉज मॉडल साइज कम हो रहा है. सो एंड स्टिल इट सिंस इट इज ज़्यादा नहीं हुआ है. अभी अगर 44 MB का फाइल अगर मॉडल बन भी गया है, स्टिल इट इज येट टू बी डन कि स्पेसी के मॉडल के साथ 5 KB का या 10 MB का 5 MB का मॉडल बन जाए, देन इट विल बी यूज्ड ऑन डिवाइस. बिफोर दैट इट इज वेरी डिफिकल्ट. अब उसके लिए लोग पाइटॉर्च मोबाइल में लिखते हैं, केरास का आता है आपका, टेंसरफ्लो का आता है, टेंसरफ्लो लाइट आता है आपका. सो देयर आर मल्टीपल वेज यू ऑन डिवाइस मॉडलिंग के लिए यू वर्क. सो दिस इमर्जिंग ट्रेंड इज स्पेसिफिक टू दैट पर्टिकुलर यूज केस. आपको लार्जर स्केल पे करना है, if it is not conversational AI, BERT is fine. Customer is ready to pay, BERT is fine. But what if the case is otherwise, vice versa? Then it is a difficult problem. So that's why knowledge distillation comes, wherein there is a network and there is a teacher network. Transformer based ही होते हैं सारे. Transformer के बारे में आप लोग पढ़ सकते हैं. Actually, it's a very good architecture जिसने that has evolved, because of which BERT became so like useful. So yeah, that is it. And उसके अलावा कुछ चीज़ें हैं जो मैं बताना चाहता था कि हाँ, BERT के अलावा एक्सेलनेट भी काफ़ी अच्छा था. एक्सेलनेट में सेम ट्रांसफॉर्मर आर्किटेक्चर था, रिग्रेसिव आर्किटेक्चर rather than encoder, auto encoder. So anyways, part, why this is important, we established it is like you have a student network and a teacher network. What does teacher network do? So basically आपके पास you have some pre-trained embeddings. Using that pre-trained embeddings, you are trying to guess on the test data set maybe, और टास्क स्पेसिफिक डेटा सेट्स, जो आपके पास लैंग्वेज मॉडल तो है, प्री ट्रेन्ड एम्बेडिंग है, बट जिस टास्क के ऊपर आपको फाइन ट्यून करना है उस टास्क, सो इट्स अ मल्टी टास्क फ्रेमवर्क, ओके, जिस टास्क के ऊपर आपको फाइन ट्यून करना है, दैट हैज टू बी यू नो लाइक यू विल गेस, अनसीन डेटा सेट है, लेबल्स नहीं है उसके ऊपर, तो बेस्ड ऑन द मॉडल व्हाट यू हैव ऑलरेडी प्री ट्रेन्ड, यू लेबल, you guess, and whatever data is generated, that is learned or mimicked by the student network, which is also a lecture. So, and what happens is कि जो कि अब क्या है कि this is more similar to spacey, क्योंकि जो student network है that could be of spacey, large data set मिल गया उसको, label उसको मिल गए, so you don't need now transfer learning, you can augment टास्क सेट का जो डेटा सेट है आपके पास, यू कैन ऑगमेंट दैट एंड बेस्ड ऑन दैट यू कैन मेक रिजल्ट्स, यू कैन मेक बेटर रिजल्ट्स. सो आपका मॉडल साइज भी कम हो गया एंड स्टिल परफॉर्मेंस इज देयर बिकॉज द स्टूडेंट इज टॉट फ्रॉम द टीचर मॉडल विच इज अगेन बर्ड बेस्ड मॉडल. सो एंड अराउंड इट देयर आर मल्टीपल पेपर्स, कभी दोनों में ट्रांसफॉर्मर है, किसी में एक ट्रांसफॉर्मर है, कोई एक यू नो स्पेसी है, देयर अदर वेज मल्टीपल आर्किटेक्चर. सो दैट इज वन एरिया आई एम वेरी फोकस्ड अबाउट, very keeping it up to date is this one, knowledge distillation, because that is my work, primary work related to it. So basically, again, as I said, using knowledge distillation, a large model is trained on the data set and then used to teach us much smaller and more efficient network. This is often referred to as student-teacher training, where teacher network adds its error to the student's loss function. Exactly. So basically, आपका loss function जो है कि student ने, teacher ने क्या predict किया और student ने क्या predict किया, दोनों के जो बीच में जो loss function है, उसको minimize करना है. So you don't need to add more data set algorithm के लिए, heavy करने की जरूरत नहीं है. With a smaller algorithms, lesser sophisticated algorithm, you can get better results by optimizing that loss function. Okay, next. And acha, so joint intent and slot filling. So what happened is कि we always in this SLU, and I mean until last year, maybe like 2018 for most probably. So until 2018 what was there कि intent detection is a separate task, entity detection is a separate task. How we do it is sequentially, एक के बाद एक, कि पहले intent निकाल लिया एक मॉडल से, दूसरे मॉडल से entity निकाल लिया, फिर दोनों को स्टिच करके एक JSON फॉर्मेट में डाला, and once you got the JSON manager, ये होता था. इससे क्या है, अगेन प्रॉब्लम, दैट मीन्स आपको इंटेंट का मॉडल अलग बनाना पड़ेगा, एंटिटी का मॉडल अलग बनाना पड़ेगा, राइट. यू विल हैव टू सेपरेट मॉडल्स. 2 GPU से आपके खर्च हुए, डबल कॉस्ट. अगर गलती से आपने 3-4 आर्किटेक्चर में हायरार्की ऐड कर दी तो यू आर गॉन, राइट. सो देन केम पीपल स्टार्टेड थिंकिंग कि एक्चुअली अगर आप इफ यू आर इन अ कन्वर्सेशन and if the conversation is about a particular topic, then the intent and entities will be always definite. More often than not it will be definite. एक fixed number of intent होंगे एक particular context में और एक fixed number of entity होंगे उस context में. And the best part is कि intent और entities जो होंगे they will be correlated. So if you can have a multitask learner model, MTL बोलते हैं इसको, multitask learner. So basically single model, you are just फाइन ट्यूनिंग ऑन डिफरेंट टास्क एट द सेम टाइम. सो आपको सेपरेट मॉडल नहीं करना, मॉडल साथ में डिफरेंट सेमेंटिक टास्क बट रिलेटेड टू ईच अदर, सो द अपलिफ्टमेंट इज देयर इन बोथ द परफॉर्मेंसेस. एंटिटी की वजह से इंटेंट में एक्यूरेसी बढ़ती है, इंटेंट की वजह से एंटिटी में एक्यूरेसी बढ़ती है. सो मल्टीटास्क लर्नर में दैट वाज द फर्स्ट एक्सपेरिमेंट व्हेन वी व्हाट वाज डन, इंटेंट और एंटिटीज को साथ में मॉडल किया जाए. दिस विल बी लाइक मोर ऑफ अगेन एक्यूरेसी इंप्रूव करने के लिए, बेटर बनाने के लिए यू यूज दैट. हाउएवर इन सब के पार, बियॉन्ड ऑल दिस थिंग, दैट 4 इमर्जिंग ट्रेंड्स, देयर आर समथिंग कॉल्ड डिस्कोर्स एंड प्रैग्मेटिक्स. जॉइंट इंटेंट एंड स्लॉट मॉडलिंग.
Is it a supervised learning problem that you're solving?
सेमी सुपरवाइज्ड.
Same as supervised, so semi-supervised. So,
So basically,
you have labels for each of the data points that you have. So is it, let's say we have 4 intents and 3 name entities, right?
Okay.
So in total you should have 12 different labels. Is that so?
No, no,
4
no.
into 3?
Different.
No.
The framework, the experiment setup of different tasks is different. Only thing is they are trained together
Okay.
from a single model. So basically क्या है कि it's a transfer learning model. Okay. Bird कैसे काम करता है? Are you aware? No. Okay. So what happens is there is one language model, and that one language model is basically, and so basically एक English के लिए I have to build just one language model. Hindi के लिए I have to make just one language model, and that language model I can use for any downstream NLP task. Any downstream NLP task. चाहे वो ये सेमेंटिक रोल लेबलिंग के लिए हो, एंटिटी लिंकिंग के लिए हो, को रेफरेंस रेजोल्यूशन के लिए हो, इंटेंट डिटेक्शन के लिए हो, यू नो लाइक एन नंबर सेम मॉडल. तो ये जो ट्रांसफर ऑफ जो लैंग्वेज मॉडल ऑन फाइन ट्यूनिंग पार्टिकुलर टास्क, ये जो पहले एक ही होता था कि एक लैंग्वेज मॉडल लिया, इंटेंट का बनाया, एंटिटी का बनाया, अब वो क्या हो रहा है, दे आर ट्रेनिंग साइमल्टेनियसली. सो एक ही मॉडल से आपका सारा काम हो रहा है. सो इसमें ऐसा है कि since the language model is already pre-trained, I don't need that much data to basically get better results.
That I got. तो इस केस में आपने बोला ना अभी कि एंटिटी और दोनों चीजें मैं एक ही बार में लर्न कर रहा हूँ.
Entity and intent joint modeling हो रही है. That means NER identify करना is a separate task. This is a different task. What I said, multitask learner, MTL. That means कि they are two different tasks, but while training, I'm training the both of them on the same BERT language model, but at the same time. Earlier it was like कि एक BERT, एक task, एक BERT, एक task. So now once the model is ready and I'm trying to host it on a Django server, I have to have two different servers, two different endpoints. But now it is not the case. एक ही model पे I can expose two endpoints and get my work done. Cool. So that's ये है. So इसके around there is lot of these are, so ATIS dataset I was talking about, SNPs is one dataset that I was talking about. So these are the top 3 from each, you know, like from on this joint intent detection and slot filling के ऊपर, on this task, and on this ATIS and SNPs, these 3 and these 3, both of them are the top papers basically. So you can, if you want, you can probably follow it up there. So that's what I have. But yeah, I was going to talk about and summarize it all over. What's, you know, like even further beyond that, whatever we have discussed, what is beyond that? Beyond that is discourse and pragmatics, discourse analysis or discourse modeling, or and also known as dialogue modeling. So basically अभी क्या है कि we are trying to be very mechanical. Like पहले intent निकालो, entity निकालो, context निकालो, domain निकालो, emotion निकालो, intonation. We know that कि, you know, like after all it's a computer, we are programming it, right? So it can never match human accuracy, never match. However, it can imitate as many nuances from the human conversation as much as possible. So what are those signals? So अभी जैसे हम निकालते हैं, intent निकालते हैं अलग से, entity अलग से निकालते हैं, joint भी modeling कर दी. Despite all that, it's you know, like the dialogue state is different from SLU. Modeling concept basically takes SLU and dialogue management put together and train together. So अभी सारी की सारी, after all it's a conversation, and conversation is made up of intents and entities largely, if you see. So अगर और state भी जो है conversation के through डिजाइन होता है. So what if we put all these things together and give them just one raw conversation into like 10 times or 1,000 times or 100,000 times. आपने एक TXT फाइल में एक conversation का जो आपका he said, she said format में रखा हुआ है, you gave like 10,000 such samples, right? And then let computer learn on its own. कि अच्छा ये इस इंटेंट के बाद ये स्टेट था, अच्छा इस स्टेट में ये 2 इंटेंट फुलफिल हो गए थे तो तीसरा इंटेंट क्या पूछना था. सो दैट मॉडलिंग, डायलॉग मॉडलिंग, दैट इज वेयर आई थिंक वी आर मूविंग, मे बी लाइक 2 years, 3 years, 4 years, I don't know how long will it take, but that is where we are heading towards, and that is what I think will be the, maybe स्टेट आर्ट हो सकता है कि 6 महीने में आ जाए. So it's, you know, like you can't say anything, it's unpredictable. कि I mean like till 2019 NLP का big problem, हम लोग TF-IDF यूज करते थे. हम लोग 2013 I was doing sentiment analysis 2013 में, तो TF-IDF वर्ड वेक्टर्स निकाल के, and then 2013 में थॉमस मैकोलोव का पेपर आया, वर्ड सडनली गेम चेंज्ड, and then फिर ट्रांसफर लर्निंग का सेबेस्टियन न्यूटन का आया, गेम चेंज.
time. Thank you so much. There, you can see him standing there. analytics and data science. They're heading all the AI initiatives at a fine. They work on a lot of cool projects that deal with issues and solution findings for real world issues. You'll get to talk to him as well as soon as his session's over. I'm going to let him take over the stage right now.
Thanks, Alan. Tanu, can we close the door? Or are we expecting people? Okay, no issues. Good evening to everyone. I'm sorry. And I'll not take a lot of time because, it's almost 4:45. I think it's a Friday evening. I'll ensure that I don't bore you with a lot of stuff that we are doing here. And also I'll ensure that I don't make a sales pitch to you, because that's another thing that I do very often. So let's start. Okay, so since I see a lot of people.
Can you not hold the mic pretty close? Just
Okay. Is this fine? Okay. So there are a lot of people here, who are first time into analytics, because I see a lot of people from our data engineering team, and I thought this slide is for you. A lot of people are asking me what. This slide might help you to set the expectations, and as I go along with the next slides, I'll actually try to give you much more context. Okay, so whenever it comes to manufacturing, it is one of the most, between all the questions that we have, this is where the world changed. Okay, so just going back to this history, 1750s we start with the first industrial revolution. Steam was discovered. The application was steam was discovered way back. Okay, mechanically powered systems, too much manual effort. Then came 1900. Electricity was available. Ford actually started mass production systems. And suddenly with the same effort we can do more. Coming to 1960s, computers were coming into fore. That actually started another level of automation. Okay, less with mass production in automation with less manual effort. We gave much more thoughts into the systems in form of algorithms, and the advent cyber physical systems that we are currently seeing here. So we are almost in the fourth revolution, where we are seeing things like AI, IoT, the enablers do more in a much more refined way, in a much more cost-effective way, in a way we can save more energy, okay, and ensure that we don't harm the environment that lot. Okay, I'll probably talk about that also. And the next leap that around the corner is the fifth industrial revolution, where we are actually doing manufacturing like a fit-all policy, but over a period of time you'll see manufacturing or processes becoming much more personalized. Okay, how many of you have watched the YouTube series on AI that is actually being aired right now? There's a Age of AI series in YouTube. So one of the I think, but I'm not sure whether it is series 8 or series 9. They're talking about food being customized. They're actually talking about agriculture being customized. Okay, so we are almost on the corner where we are going to feed all this cognitive awareness into machines using general AI and super AI. It has to happen. Of Industry 4.0. Now, what are the key enablers? So we have this. So we always had from 60s when the electronics and computer systems came. We always had sensors, but we have figured out a way to ensure these sensors communicate to each other, and that's when the IoT was born. The internet and the sensors combined together. When these get combined together, they generated a new dimension of data. So there was structured data, there was sensor machine generated data, then there is video data, unstructured data like video, feeds, noise, sounds, etc., etc. Okay. Now, then to store the data came the big data system. It actually happened. So when we have a lot of data, we have to do processing at a scale. That's where the true AI happened. Okay. So 1960s where the actual neural network started, but we were able to see feasible AI ML because of large amount of computing power that's available to us. Then from silo computing, we are actually gradually going towards cloud computing. Okay, we see a lot of our customers are actually moving to cloud, owing to and as the cloud features like securities and other things are improving, customers are finding more and more confident to adopt cloud. Okay, so because if you see a larger time frame, doing everything on cloud will be much cheaper. Again, different people have different point of view towards it, but the services that we are seeing, cloud building can be much more cost effective. Okay, these are more on the process part that I. Coming to the left hand side, we are seeing a lot of a new type of in 3D printing, which is a part of a larger domain called additive manufacturing. Okay, then there are robotic systems. Again, but we are actually making them we're actually giving them more data. We're actually giving them more decisions to make. Okay, in augmented reality system, even if you are making any change in your plane design, you can actually go back to a simulator and can design or can play around with multiple other scenarios to test your product in a much more holistic way. Okay, so I just I spoke about industry manufacturing. I'm kind of going to shift. Pardon me for that. So, typically when I talk of manufacturing, so these are broad functions within a manufacturing industry. There might be many, but this is more popular function. So, one of them is the financial planning analysis. It does demand forecasting. It says, how much to produce, what to produce, how much to produce, when to produce, what price to produce, and what are the raw materials cost you would need them. Then comes the operations part, where you have the labor forecasting, labor optimization, you do the production schedule, which basically talks about how do you basically plan the overall manufacturing cadence, that you meet a particular service levels, then you monitor your production on an ongoing basis, and also ensure that your overall management while you're in operations, your assets might get damaged or they might show fatigue over a period of time. How do you basically manage those assets? Then there is supply and logistic, which you have to take care, ensure that you are so much more balanced and optimized fleet and systems. Then the design, we do new product and do new product testing. Then comes the regulation and safety, ensure that whatever the you don't pollute environment. Ensure that your workforce are not subjected to any risk, and you also ensure that there is no workforce production hazards. The reason I'm talking about the landscape is, as an organization, we are working with multiple clients, multiple Fortune 500 clients, across all these dimensions. Okay, so what we will do next is, pick up very few a subset of problems that we are solving for our clients, and which are a little different in terms of how we are ensuring that we create a better asset management system, or ensure that workplace regulation safety is managed, or a production monitoring system is in place with creation of digital twins, so that the overall manufacturing processes are much more optimized. Okay, so these are some use cases I'm talking about, Am I audible? Okay. I keep on fluctuating the mic, I just realized. So, client success stories we'll talk about. The first is one of the work that we have done for a leading automotive giant. So the problem there was, Balu, can you just meanwhile try to click that link? Yeah. And I'll try to relate how it is actually getting into other clients also. These are few demos that we have made for this purpose. These are no way the final, application that was built because we have to ensure that we maintain our client safety, client, NDAs and their knowledge are not leaked out. So one of the first problem that we'll talk about is the corrosion problem. So if you see any system, they're bound to have this metallurgical failure. They're bound to develop corrosion. So the overall task that we did was, how do we identify a corrosion and what kind of corrosion it is, or what severity it is. So, again, so there are, if you see on your screen, below there are some 5, the top 5 corrosions that we have taken here for demo purpose, but there were, more than that. The idea is, how do we take this, what kind of change we can bring around a process which typically has been driven much by subject matter experts. So before we came in, the way it was happening was there used to be a subject matter expert, who had at least 10 plus years experience in, automotive QA, and they would then probably look at the image and give it a particular score. If you show the same person the same image after a certain point of time, in different point of time, he will actually give you a different answer. Okay, because human being, when they think very localized way. They think in a contextual and localized way. Okay, so what we did was we actually built a computer vision model which was using the dense net architecture. Okay, and what the impact that got created was the system that used to take typically a week for a subject matter came down to almost instantaneously. Okay, so the way it is getting implemented right now, again, this was when you developed, this was much more of a proof of concept. But now we have seen this getting implemented into their internal systems. The overall idea is to basically put it into a production phase, where a production line, and whenever each and every operation that happens, like a paint operation, there is a forging operation, there is a casting operation, so at each and every operation points, an image will be captured, and different kind of, it will basically identify whether there is a rust or a corrosion inside it. Okay, I'll just move to the next one. Balu, just can you stay on that image? Let it be. Okay. The second problem that we solved was on something called catastrophic modeling, and I'll explain how manufacturing organization can use it. So we were working with an insurance client, and the insurance client was trying to identify what premium a chemical manufacturing plant should pay. Okay. So premiums are generally decided on proximity to something like a water body, or there is a residential area close by, what kind of roof pattern it has. Can we click on that arrow? Okay, so if you see the right, in terms of things like, again I was saying, what is the proximity to the water body, what kind of cluster density, whether it is in a residential area or non-residential area, whether the residential area is very dense or whether it is scattered, what kind of roof type it has a flat roof or a corrugated roof, what kind of building symmetry it has, whether it actually has a parking lot in one side or the parking lot is scattered all over. So these kind of input parameters help an insurance company to identify what should be the premium for particular estate B. Okay. So if you can see here, on left again, these are some demo images I have taken. So the left, if you see left hand side, these are the kind of images or kind of data that was available to us. So again, these were from satellite. So they were, so they can be something like a multispectral images. They can be something like a panachromatic images, and something like a backscattering. Backscattering is you basically just talking about. It's actually has a 600 meter wavelength it goes, and then you basically see what is the reflection and how much of the energy has been dissipated. Okay, so if you so there are two broad models that we have built here. One is a image classification model. So image classification was to basically identify what is the roof type, what kind of building symmetry. Okay, so what we typically do is we take the data and say, hey, here's a photograph of a corrugated roof, here's a photograph of a flat roof, here's a photograph of a asymmetric building. So these are the labels that we create. And the other two, which was cluster density and proximity water body, we use as a segmentation model. What is segmentation model? As you can see here, again, we'll basically call out the area of interest. We will take a satellite image and we'll basically call out the area of interest, saying that this is what cluster. Suppose if it is a high cluster density, then I'll actually have no number of white patches here. If there is a proximity to water body, I'll again have a white patch, but I'll use the instance segmentation. Which part of that was the water. Again, so when we do any image processing, we do a lot of pre-processing itself. It's like an EDA. So when you have data, right, you basically play around with your data, seeing that, okay, what are the outliers, what are the missing values. We also try to do, those kind of activities here. So masking was one form of pre-processing. Then we'll actually do some kind of channel isolation. Now there's a water body. Probably water body will look, it's a blue color unless it's very muddy. Okay. So we'll isolate the blue channel and take it and then do the masking, and that actually becomes our labeled data set. Okay, and then sometimes what happens is the satellite images, we try to simulate a lot of behavior like a cloudy behavior. So probably I'll use a lot of transformations like graining, or I'll actually blur the image a little bit so that it tries to learn different kind of scenarios which might happen in future. Okay, can you go back? So the third one is the work that we have done in product design. So before any new designs are launched, so typically in automotive industry, what happens is someone will draw a CAD model. Okay, it goes for some presentations. It will do some rendering in the CAD model. It will go for the presentation. Okay, if the presentation, then it goes for some kind of 3D printing. Now in the CAD, what happens is you are basically drawing something. Suppose if some of the edges are empty, Balu, can you click on that right arrow on the bottom? Yeah. So suppose this is a CAD model. If there is an empty space, now you put it into 3D printing. The entire 3D printing operation fails, and you cannot stop the 3D printing operations because it has been pre-programmed, and the epoxy for 3D printings are very, very costly. So before we came in, this entire process used to happen manually. So fixing one CAD models, end to end with QA, with validation, used to take almost one person for close to a month. I'm actually showing a very simple image, but those are just imagine you have a car engine. A car engine will actually have multiple deformations, multiple shape size on top of it. So what we did was we created an image model which is called Graph CNN. So I'll tell you the complexity of this model. Okay, now the typical models or typical transfer learning models that are available in the market, they are trained on regular objects like bus, truck, humans, animals, those kind of things. Little complex than that is a face recognition. In a face recognition, it's a person, it's basically identifying those finer details of a person to basically distinguish one person from the other. Now, in that analogy, suppose if I give you two skeletons of a dead man, okay, let those dead person be A and B, and I'm basically trying to figure out who is A and who is B, where the skeleton looks very, very similar. So just think like, graph CNN in a layman term is doing image analysis or image processing on a skeleton, where you don't have any features other than that, odd looking, bones and jaws that you can see on the skeleton. Okay. So what we do is, we said, okay, fine. We'll do it in two steps. The first step is we use a graph convolution to figure out where the gaps were. Okay. So this is how the gaps, and we did some, post-processing step to basically come, to come at the post-filling part. Okay, where you can see larger triangles. The problem with larger, now what I can do is I can actually take this and then put it into a, in a 3D printing shop. Now wherever the triangles are larger, it will try to create a flat profile. Okay, so a sphere might look like, some sphere which has, edges sharpened off. Okay, so our task is to basically get to the right bottom where we have equilateral triangle spaced out equilaterally where all the edges are kind of meeting each other. So again, once we use this course, we have got the course object, then we use something called minimum intrinsic dissimilarity. It is just a pattern matching. Okay, what we do is we actually have some sure that all our, so whatever the triangulation happens, they are actually following that particular constraint. Okay. So the advantage was, post this, probably the entire analysis came down to a couple of days. Because, again, these are very, graph convolution is a very, very memory intensive algorithm. Okay, so it takes a lot more time to process it. Can you click the home button this below? Yeah. The fourth one I'll talk about is another interesting work, which in the space of predictive maintenance. Can you just click that? I'll show another demo here, but before that, click that. Click the link. So I will show a demo here. So typically what happens is there are this huge manufacturing, machines, and every machine when it runs in a normal time, they have a particular sound profile. Okay, and whenever there's an issue, this profile changes a bit. Okay, so we took advantage of it. Okay, and again, what I can call is this is not a completely voice recognition exercise, but what we did was we took a sound profile. Okay, but if you can play the normal sound. Just pause it. So we create a spectrogram out of a given noise profile, and the spectrogram became the image. Now, making this as a standard image, we can then do simple image processing to basically figure out if there is a deviation, and if the deviation, what kind of deviation it is. If you can do the multi-acoustic profile. Just pause it. Yeah, for the demo, we actually ensure that we pick the best noise. Okay. So if you see, on the right hand side, there's an amplitude time chart, then there's a frequency time chart. So these actually becomes a channel. Okay. And typically, all those models that we have work good on RGB channels. Okay. So for the third channel, we simply take a zero column matrix, and that's how we ensure that we actually have a 3-channel data, and then we do image processing on top of it. So currently we have used the regular architectures like ResNet 50. We are also trying ResNet 34. We couldn't use graph convolution networks over here, while those have been very, very specific. The reason being, these have to be implemented on an edge device. Okay, so probably on a Raspberry Pi. Okay, so another good news is while we are doing at that point of time, Raspberry Pi 3 was there. Now Pi 4 is available, and Pi 4 is more RAM. Okay, so we can, that gives us flexibility to build a little larger model. Okay, so again, this is a proof of concept that we have developed, and we are trying to it's actually web right now, but the overall idea is to tone down and ensure that it actually can be implemented on an edge device. Yeah. Okay. The fifth problem that I'll talk about is creation of a digital twin. As I mentioned, right now we are getting into cyber physical systems. Okay. I want to understand that if we do some kind of operations on any physical device, what would be the possible outcome be? And if the possible outcome is favorable, then we'll actually then implement it on a currently, you can click that right button. So the problem we are solving is for an aluminum manufacturing company. Typically, if you see on the left hand side, there's an aluminum smelting pot. So each production line actually has 36 such pots, and there will be at least 10 production line in a given aluminum system. Working for has actually 10 lines. There can be much more for some other people also. So then there are data which are actually hosting on multiple systems like multiple machine system like SCADA. Then there are historical data on SAP system. Then there's some unstructured data that they have collected like say noise, image. Through that we are actually building a data lake. From that we are trying to do three things right now, but the overall idea is to ensure that we can simulate the entire factory onto a virtual system. Okay, so probably it's a 2-year-long project, but we'll do it whenever it comes. So currently we're trying to identify, so this is just like a pyramid. So each pyramid is called a cell. Inside a cell, there will be a anode. The work of the anode is to ensure that it's a negatively charged. So the work of positively charged. The work of the anode is to ensure that all the non-aluminum oxide things move towards it, and the aluminum settles below. So the cell is inside a pot, and the anode is basically what is actually happening. What is actually separating the aluminum from the bauxite ore. Okay. So if you can go to the next slide. So the overall target here is to basically show how we are doing AIML at a scale. The other work that we spoke about was basically, which is much more static. This is much more dynamic systems where you have multiple data sources coming in. We are actually trying to process data using batch data systems, real-time data systems like Kafka. Then you actually can see there are the IoT edge platforms. This is actually helping us create the digital twin system, which is again sorry the digital twin system is just like a augmented reality system. Okay, so those are the two products like ThingWorks and Vuforia. And there's a visualization which is actually working. We have shown Power BI and Kibana, but we will actually move to a web-based UI in future. And this is basically where our Himalaya models are there. We're actually using a service from HP which is called Data IQ, which is helping us manage our models much better. Home. Just go back. Yeah. So the last one is, a virtual an assistant that is being developed in our AI COE. So there are some other cool projects that we do in AI COE, but currently we haven't seen some of their impact on manufacturing. But one of the virtual assistant that we are developing, and I was talking to Vishwanath right now on taking help on how we can do that better. So again, this is one of the requirements that core manufacturing organization. So the overall idea is whenever there is a defect, okay, not everyone would know what the defect is. So we are asking the person that, you upload the image, you basically, then you put some text in terms of what is your idea about it, what how it happened, why it happened, in case you are aware of it. Okay, so this actually goes in what framework. Then we are using image classification to identify what product it is. If it has a barcode, then we'll actually use OCR to identify. And if it takes a much larger image, we actually can take our image from little far. We can identify what product it is actually, damage it has. Then there are text messages. We are doing text analytics to figure out what is the user input on top of it. Okay. Then there are user manuals that are already in place. So the scale that I am talking about is at least there will be a million plus user manual with this client. Okay. Then it does a text search, and in the text search it might actually find that at least 15-20 different ways. Okay. Then using natural language generation. Okay, then it will feed into a issue management system. From the issue management system, it will figure out what the call to action will be. So again, something that we are actually developing. There are a lot of small other components that the team is working on. One of the component that we are talking about is a natural language querying. How do you convert a natural language into a SQL syntax? Okay, which can then go out and figure out what call to action needs to be taken. Okay, then there are for product application and for damage detection, we're trying to use a little bit of one-shot learning in terms of, now if there's a corrosion, need not be trained for different kind of corrosion itself. Suppose there might be a hole, but even if it says that, which actually has some brown patches, but even if it says a corrosion, it's a call to action for someone there. So there's some nice innovative things that we're doing right now. Things like supervised learning, so that we don't depend on lot of this data sets. We can do more with less data sets. Okay. Let me do a quick time check. Sorry. Yeah. So. I'm actually done with my presentation. Any questions you guys have? Sorry? So text messages are a user input of what he has seen. Suppose he has probably picked up a, there is a hole. Probably I'll say that, how was this hole created? Are you aware of it? Probably he might say that, yesterday the hole was not there. Or probably if there is suppose a joining pipe, he said this is, a welding was done very, very recently. So these kind of text inputs will take. Okay. I'll just go back. Home button. Any other work that, so the idea was to show you the kind of work we are doing, and any other work that you want a little bit deep dive, we can still do that. We have 15 minutes left. It seems people are happy that it finally got over. I think we can wrap up if there are no more questions. Alan? Unless they have questions, I think, and I have done so. I thought of giving a brief overview of all the cases, and I was expecting if someone wanted to, get deeper into how it is being done. We have 10 minutes. We can definitely do that.
Yeah, meanwhile, if you guys can also fill out the feedback form, that'll be very helpful. Can I also hand over the Hampers?
Thank you guys so much, and thank you Saurabh, thank you Vishwanath, and it was really a very interesting session. Hope everybody enjoyed it. Cool. So we'll just have a little token of appreciation for both of you. Thank you guys. Thank you. Can we collect the survey forms? I mean, if it is filled. Yeah.
Thank you guys for coming here today. We'll do this on a monthly basis. So if you have any personalities that you would like to see on stage, if you want to meet with them, if you have questions, we can make that happen for you, or at least we'll try. So let us know. Let us know what you think. Let us know what can be improved. Give us your feedback, and have a good evening. Thank you.